Valve Selection Basics. Understanding international standards for control valves. In industrial automation, valves play a vital role in ensuring safe, efficient, and repeatable process control. But not all valves, or valve standards, are created equal. In this Valve Selection Basics video, we'll break down the key international standards that govern valve design, testing, and performance, and explain the difference between standards for on-off valves and control valves. On-off valves, like ball, butterfly, and plug valves, are designed to fully open or fully close with minimal leakage. Their standards emphasize tight shutoff, flow capacity, and mechanical integrity. Control valves, by contrast, are designed to throttle flow continuously and respond to control signals with precision. Their standards focus more on dynamic performance, leakage classifications, actuation, and positioning accuracy. This functional difference drives separate sets of applicable international standards. Commonly referenced standards for on-off valves include API 6D for pipeline valves, defines design, inspection, and pressure testing requirements. API 598, standard for seat leakage and shell testing for all valve types. ISO 50208, provides leakage rate classes A through G, especially for tight shutoff valves. API 607, ISO 10497, fire-safe test procedures to ensure valves maintain seal under flame exposure. In these applications, valves are generally tested in the fully closed position, and zero leakage or near zero is often a requirement. Standards for control valves. For control valves, the standards emphasize throttling behavior, actuator response, and performance under dynamic conditions. Common references include ASME B 1634, defines design criteria, pressure temperature ratings, and wall thickness for all valve types. IEC 60534, a suite of standards specific to control valves, covering valve sizing and flow characterization. Performance testing, noise prediction, seat leakage classifications. ANSI FCI 70-2, widely used in North America to classify control valve seat leakage from Class 1, no test, to Class 6, very tight shutoff. Control valve standards also require testing under partially open positions, a scenario not typically covered in on-off valve protocols. Cryogenic applications, specialized standards. When it comes to cryogenic service, both control and on-off valves may be subject to specialized standards like BS 6364, 1984, for design and testing of valves at cryogenic temperatures. MSSSP 134, US-based spec for helium leakage and thermal cycling. NASA 5400 GT08, even stricter requirements used in aerospace cryogenic systems. Cryogenic standards test leakage rates with helium gas at -320 degrees Fahrenheit, often allowing only a few cubic centimeters per minute depending on valve size, regardless of whether it's on-off or modulating. At Trimteck, our OPGL, OPTB, and OPEXL series valves can be engineered and tested to these cryogenic standards, and to tighter customer-specific limits if required. Fugitive emissions and fire-safe requirements. Valves in critical environments must often meet ISO 15848-1 for fugitive emissions performance through valve packing. API 624, North American standard for emissions from rising stem valves. API 607, ISO 10497, fire testing for soft-seated and metal-seated on-off valves. These standards are particularly important for valves handling hazardous or flammable media where leakage, even through the stem, must be minimized. Material, design, and quality standards. Regardless of valve type, key design and manufacturing standards include ASTM or EN material specifications, ASME Section 9 for welding qualification, ISO 9001 for quality management systems, project or customer-specific documentation packages, for traceability, PMI, or special testing. Trimteck maintains full traceability and documentation for every valve we ship, from raw material to final assembly, in compliance with your industry's expectations. Why it all matters. For end users and specifiers, knowing which standards apply to your valve type helps ensure safe code-compliant installations. For manufacturers like Trimteck, understanding the difference between tight shutoff and precise throttling, or fire-safe integrity and dynamic flow control, is essential to building the right valve for the job. Whether it's API, ISO, ASME, MSS, or your own internal spec, we're ready to deliver. To recap, on-off valve standards focus on shutoff, pressure containment, and fire safety. Control valve standards focus on throttling performance, response time, and dynamic leakage. Cryogenic, fire safe, and emission standards may apply to both, depending on the service. Trimteck tests and certifies valves to all major international standards and can adapt to customer-specific testing and documentation requirements. At Trimteck, we engineer and manufacture control valves that meet your performance needs and the standards that govern them. Visit trimteck.com or contact our team for expert guidance. And if you found this video helpful, don't forget to like, subscribe, and hit the bell for more engineering insights from Trimteck. Thanks for watching.